Hello again and welcome to Engineer's Mindset. Now let's talk about trigonometric rules. Let's say I'm given this right angle triangle ABC. Let me say the side that faces A should be called A. Let's call this side A, and let's call the hypotenuse arm B since it's facing B, and let's call this side C since it's facing C. And let's now put an angle here, theta. Remember in the last video I said wherever the angle is facing becomes the opposite. So since the angle is here, it means AB is the opposite, and AB happens to be the distance between A to B is simply what? C, and distance between B to C is simply A. Distance between A to C is simply B. Alright, so let's talk about the rules. The rules state that the sine of the angle theta is sine theta is given as opposite all over hypotenuse. Okay, so that means now that sine theta is equal to opposite. The opposite arm is the side directly facing the angle, that's AB. So sine theta is simply opposite AB. So we'll have AB all over hypotenuse AC. Okay, so this is AC. So you can simply say this is okay, this can simply mean that sine theta is simply opposite is AB. Distance of A to B is simply what? C. So we can write C all over, and then hypotenuse, which is AC, distance is B. So sine theta is simply C all over B. So this is how to define the first trigonometric rule. Sine theta is simply opposite all over hypotenuse. The next trigonometric rule is cos theta, and cos theta is simply adjacent, is defined as adjacent all over hypotenuse. Okay, so this means that cos theta is equal to, from the diagram, the adjacent side is the one backing the angle. Remember, the longest arm remains the hypotenuse. The side that faces the angle is the opposite, which is this, directly opposite to the angle. Meanwhile, the side that backs the angle is called the adjacent arm. So in this case, BC is the adjacent. So sin theta is adjacent, cos theta, sorry. Okay, so cos theta is adjacent. Adjacent is BC. BC all over hypotenuse is A. Hypotenuse is AC. So adjacent all over hypotenuse AC. So we can simply now rewrite that cos theta is equal to the adjacent arm. The distance between B to C is A. We called it A. So adjacent is A all over hypotenuse is A to C, which is simply B. So B. Alright, so by definition, cos theta is simply adjacent all over hypotenuse. Okay, another term we'll talk about is tan theta. Okay, tan theta is simply opposite all over adjacent. Alright, so if we take a look at the triangle again, opposite arm is this, and then the adjacent is this. So it means that tan theta is simply opposite, that's A to B. So you have AB all over, adjacent is B to C. So all over BC. And of course, you know that opposite arm is simply distance between A to B, and that's C. So tan theta is simply C all over adjacent. Distance between B to C is simply A all over A. Alright, so this is the third definition. So we've talked about sin theta, we've talked about cos theta, and then we are tan theta. Now a careful look at let's say we divide sin theta by cos theta and see what we are going to have. Okay, so let's divide sin theta by cos theta, and we observe that sin theta was given to us as C over B. So we'll put it out. We are simply saying sin theta, which is C over B, divides by tan cos theta, and cos theta was given to us as A over B. So we'll have A over b. Now by trigonometry, sin theta is over cos theta is now equal to, okay, so I have c over a, I have divided by a over b. Okay, so from board mass, removing this division sign, we can, okay, before doing that, okay, this is simply c over a, sorry, c over b, c over b, okay, divides by, so see this division sign, divides by a over b. Okay, so sin theta over cos theta is now equal to, now by board mass, c over b. If I'm changing this division sign to multiplication, okay, it means I'm not going to write the inverse of what it is, that's the divisor. Okay, so this becomes times b all over a. If I'm changing the division sign to multiplication by board mass, it means I have to change the position of the divisor. So this comes up and this comes down, so you have times b all over a. And from here, sin theta over cos theta is now equal to, this is c times b all over b times a. So c times b, b times a. So notice that b can actually strike b out, so I'm left with c over a. So this implies that now that sin theta over cos theta is simply c over a. Okay, so if it is c over a, but look at what we obtain here for tan theta. We also obtain tan theta here as c over a. So it simply now implies that tan theta, this is now same thing as what? Tan theta. So it also now implies that tan theta can also be written as sin theta all over cos theta. Alright guys, I'm going to pause the video here, and in the next videos we'll start doing calculations using these trigonometric identities. Thank you very much. Share your comments. Okay, thank you very much. Share your comments if you find this video very interesting. Let me know what you think about the video. I'll see you in the next video. Thanks.